So, we are back again, guys, and this is our fourth topic, which is magnetic force acting on a current carrying conductor. So, if a magnetic force is exerted on a single charged particle, when the particle moves through a magnetic field, a current carrying wire also experiences a force when placed in a magnetic field. So, this is our first figure. So, as you can see, meron tayong horseshoe magnet in between in between the horseshoe magnet is a uh, wire, current carrying conductor. Wire, wala pang current dito. So, we can view on the side view, ito yung makita natin. So, when there is no current in the wire remains vertical. So, it will still remain vertical pag there is no current. So, yan. There's no current, vertical pa rin siya. Pero, when the current is upward, the wire deflects to the left. So, pag yung current daw is papunta sa taas, upward, yung wire ay na-deflect sa left. While if the current is downward, the wire deflects to the right. So, a wire suspended vertically between the poles of the magnet. So, the total magnetic force is on the segment of wire of length L is magnetic force, charge velocity times magnetic field, multiplied by N, in which N is the number of mobile charge carries per volume. And we have a segment of L here, which is A and the length. So, yan yung volume niya. And since I is equals to NQVA, the total force on a segment of current carrying wire is magnetic force is equals to I times length times the magnetic field. Pero makuha din natin to sa can also have can also derive this equation from the magnetic force equals to charge velocity times the magnetic field. And since velocity is equals to uh, length over time, kasi di ba yung unit ng velocity is meter per second, so length per time. We can substitute length per time as uh, wait, we can substitute length over time to v, and that will equal to q over t times length multiplied by v. And since yung unit ng current is coulombs per seconds, that is ampere, charge over time is equals to current, and that will give us the equation of the total force on the current carrying wire. So next. So we have a segment of arbitrary shaped wire carrying a current I in a magnetic field B, uniform magnetic field B, which experiences a magnetic force. So the magnetic force on the segment vector length ds, so this ds, doing that, is dfb is equals to I ds, so this is the length from going back to our equation, times magnetic field B. So integrating both sides, the total force acting on the wire is magnetic force equals to I with the upper limit of B and the lower limit of A, and rubber length D sub S times magnetic field B, in which A and B are the endpoints of the wire. So it is A from point A to point B. So yeah, that is our length. Yeah. So we have our fourth example, which is force on a semicircular conductor. So a wire is bent into a semicircular radius R, forms a closed circuit, and carries a current I. The wire lies on the xy plane and the uniform magnetic field is directed along the positive y-axis. Find the magnitude and direction of the magnetic force acting on the straight portion of the wire and the curved portion. So let's find the and the direction acting on the straight portion, so straight portion, and on the curved portion. So we can use the right hand rules, and we can see that the force F1 is on the straight portion of the wire. So dito, and out of the page. So dun sa taas. And yung force naman ng F2 is on the curved portion. So this is the F2, force F2. So because we are dealing with a current carrying wire in a magnetic field rather than a single charge particle, we can use equation 29.12 para para mahanap natin yung force ng each portion ng wire, which is the straight and the curved. So, wait. So we notice that ds is perpendicular to, so this ds, it is perpendicular to magnetic field. So we can use equation 29.12. So magnetic force equals to I upper limit B and lower limit A ds times magnetic field B, and that equals to current I and the upper limit of R, the lower limit of negative R. So since yan, is negative, diba dito? So yung lower limit niya is negative. And B dx K equals to 2IR BK. So equals to 2IR BK, and ito yung uh, magnetic force sa straight portion. So to find the magnetic force in the curved part, we must first write the equation, write an expression for the magnetic force BF2, in which that equals to I ds times magnetic field B, and it will equal to negative IB sine theta dsk. So you can write an expression for d sub s, in which it equals to r d theta, and the magnetic force on the curved portion is equals to negative the upper limit of pi or limit of 0, IRB sine theta d theta. So integrating the sine theta, we will have negative cosine theta with the upper limit of pi and lower limit of 0. So Calculating that, we will have a total of, and we will have the equation for curved portion, which is negative 2ir d k.